This is SpaceTime Series 23, Episode 78. Coming up on SpaceTime, the Hayabusa-2 asteroid sample return capsule to land in Australia, NASA's James Webb Space Telescope, the replacement for Hubble, now set to fly on October the 31st next year, and a converted intercontinental ballistic missile used to launch a new spy satellite for the National Reconnaissance Office. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The Australian Space Agency has confirmed that Japan's Hayabusa-2 asteroid sample return capsule will touch down at the Woomera Rocket Range in Outback, South Australia on December the 6th. The Japanese Aerospace Exploration Agency spacecraft was launched aboard an H-2A rocket from the Tanegashima Space Center south of Tokyo on December the 3rd, 2014, on a mission to study the near-Earth asteroid 162173 Ryugu. Hayabusa-2 arrived at Ryugu on June the 27th, 2018, deploying 4 small rovers onto the 950-metre-wide space rock's surface. The 610-kilogram probe studied the asteroid for a year and a half, eventually firing a projectile into the surface and collecting ejected debris flung into space from the impact for return to Earth. Hayabusa-2 collected and stored the samples in separate sealed containers inside a 40-centimetre thermally insulated sample return capsule. Hayabusa-2 left Ryugu in November 2019 for the return journey to Earth. When the spacecraft flies past Earth in December, it'll release the 16-kilogram sample return capsule. Spinning at 1 revolution every 3 seconds, the capsule will re-enter Earth's atmosphere at 12 kilometers per second and deploy a radar-reflective parachute at an altitude of around 10 kilometers, ejecting its heat shield and triggering its tracking beacon. Touchdown in the outback of South Australia will mark the conclusion of its mission after travelling more than 5,240,000,000 kilometres. Once on the ground, recovery teams will safe the capsule, securing any volatile substances before the sealed containers are open. This is SpaceTime. Still to come, NASA's James Webb Space Telescope, the replacement for Hubble, now set to fly on October the 31st next year, and a converted intercontinental ballistic missile used to launch a new spy satellite. All that and more still to come on SpaceTime. Well, after decades of development, NASA's James Webb Space Telescope has completed one of its final ground tests before next year's launch. Engineers and scientists have now completed the telescope's comprehensive systems test at Northrop Grumman's Redondo Beach facility in California. The critical software and electrical systems analysis test is one of the last before preparing the telescope for placing it into its launch configuration in preparation for next year's flight to space. James Webb is the largest and most technically complex space science telescope ever built. Engineers have been working 24 hours a day for 15 days straight, executing over 1,000 scripts and instructions in the 1,370-step process. This comprehensive systems test establishes a baseline of electrical function and performance. In a few months' time, after the telescope completes its next and final set of acoustic and vibration tests, designed to simulate the rigours of launch, the team will run another full system scan. Engineers will then compare the before and after results, which should be the same, indicating that the spacecraft is operating as intended and that it will withstand the launch environment and will operate as designed once in space. You see, unlike its predecessor Hubble Space Telescope, which was based on an existing keyhole spy satellite design, modified to look up into space rather than down onto the planet's surface, James Webb was designed and built from scratch, with work starting back in 1996. And also unlike Hubble, which orbits the Earth at an altitude of around 547 kilometres, making it accessible for service missions, James Webb will orbit the Sun in Earth's Lagrangian L2 position, a sort of distant gravitational well, directly on the opposite side of the Earth from the Sun, and travelling with the Earth as it circles the Sun. The telescope will be in a halo orbit ranging from 375,000 to 1.5 million kilometres from Earth, much too far away for a service mission. James Webb will change science's view of the universe. Its 6.5 metre diameter gold-coated beryllium reflector will have a collecting area over 6 times larger than Hubble. It'll see the universe in mostly near-infrared wavelengths, looking at primordial celestial objects whose light has been stretched into longer wavelengths by the physical expansion of space-time itself. This will enable James Webb to look at some of the earliest galaxies and stars, which formed shortly after the Big Bang some 13.82 billion years ago. But it certainly hasn't been a dream run. There have been ongoing technical challenges, and then there's the COVID-19 pandemic. Combined, these have conspired to repeatedly push back the launch date for James Webb. It's now slated to fly from the European Space Agency's Kourou spaceport in French Guiana on October the 31st, 2021. We'll keep you informed. This is SpaceTime. Still to come, a converted intercontinental ballistic missile launches a new spy satellite, and later in the science report, the experimental COVID-19 vaccine mRNA-1273 shown to boost immune response in early trials. All that and more still to come on SpaceTime. Today's edition of SpaceTime is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
You're listening to SpaceTime with Stuart Gary.
We often talk about the spectacular panoramic vista provided by the southern night skies, a view many regard as being superior to the skies of the northern hemisphere. And, well, it's true. The southern celestial sphere contains all the good stuff. There's an astonishing array of beautiful deep sky objects, including the naked-eye galaxies, the large and small Magellanic Clouds, stunning star clusters like the Jewel-Box Open Cluster, and the globular clusters 47 Tucani and Omega Centauri. Then there's the Helix Nebula, the Coalsack Nebula, the hourglass-shaped supernova 1987A, our nearest neighbouring star system Alpha Centauri, and of course unique constellations like the Southern Cross. And imaging these objects isn't all that difficult, as Australian Sky and Telescope editor Jonathan Nally explains.
When you first begin to learn about astronomy and get into amateur astronomy and start to learn about night sky, you come across a term called deep sky object, a deep sky object, right? Now, this refers to any sort of object like a star cluster or a nebula or a galaxy that is way, way, way beyond our solar system. Well, all of those things beyond our solar system. We don't have them in our solar system, but these are way, way, way. Anything that's a long way beyond our solar system. And not stars. Stars are sort of common, but then we're talking about these sort of other larger sort of objects like galaxies or
globular clusters and
the
Lagoon Nebula and
big
things like
gas
this.
clouds, that sort of thing. Yeah, anything like that. So they're called deep sky objects because they are a long way away. They are deep into space. So in our July issue, we take a look at the first major catalogue that was done of a particular class of these deep sky objects, and that is nebulae. And the catalogue was called the Sharpness Catalogue, named after an astronomer called Stuart Sharpness. Stuart, there you go. He published a catalogue back in the 1950s of lots and lots and lots of these amazing nebulae. Now, there are some famous ones in this catalogue, like the Crab Nebula and the Orion Nebula, and there are other ones that you probably haven't heard of before, like the Tulip Nebula and the Veil Nebula. And a lot of these ones are named after what they look like, either through a telescope with your eye or with photographs that have been taken. So we take you through which ones you can see and when and where to see them. And what we also do in the current issue of the magazine is we look at deep sky video. And this is how to take special astronomy video cameras and attach them to your telescope and get amazing pictures that way. Some people like to take, well, most people like to take still pictures of planets or stars or galaxies or whatever, but you can also use video. And there are a couple of advantages to this, or reasons why you would do it. One is that sometimes when the seeing, as astronomers call it, is not too good, when the atmosphere is a bit blurry and the wind currents up there are disturbing the air and so everything looks to be twinkling, Sometimes if you take a video where you're getting many, many frames taken per second, if you then go through the video later on, sometimes you find just instant moments of where the air is still. Like just for a fraction of a second, you just catch it when the air is still in between air currents moving around, and you can get a really sharp picture. So you can get great shots that way. But the other real advantage to using video is that you can attach it to your telescope outside, and you can run your cable from your video machine to your laptop or computer, which can be either be with you outside or inside where it's nice and warm. And so instead of having to look through a little eyepiece in a telescope, you can see whatever the telescope is seeing up on your computer screen.
Now, you often hear of people who have, they've bought a block of land in Los Angeles or somewhere, although they live in Sydney, and they're actually running a telescope in another country, in the US, for example. And they would use that sort of setup there, I guess, too.
You can do that with either a video camera or still cameras. Yeah, automated. You get a block of land, and you can stick an automated telescope with an automated observatory dome, automated cameras, everything's computer controlled, and yeah, you can just set it running, and it can even be so clever these days that you can attach like a weather sensor to the observatory to tell when there's clouds or not. So if it's cloudy that night, don't bother opening up, or if it's raining or whatever. You can do all that sort of automation where you can observe from the comfort of your home while the telescope's out there doing its work. And in fact, some people who really like to get into astrophotography of a serious kind, where you do need to take long exposures and many, many multiple exposures, perhaps through different coloured filters. So it can be hours worth of work involved in doing that. Well, instead of having to be out there in the dark at night when it's cold in your observatory, you can just get it. You can set a computer program, put the whole schedule of what photographs need to be taken and when, and send it to the telescope, and it just works out when to do it. And it'll just do it. And if it doesn't get them all done tonight, it'll try again the next night or the next night until it's all done. And then the data appears in your computer, and there you are. You've taken some photos without having to lift a finger. So it really is amazing the level of technology that's available these days. And some people, as you suggested, do set up their own observatories like this. But there are plenty of telescope farms, I guess you might call them, that have been set up in lots of countries around the world. And you can just get on the internet and buy an hour's worth of time on one of these telescopes, and it could be on the other side of the Earth. So you can take a photograph or a video or something of something that you would never get to see from your part of the Earth because it's in a part of the sky that you just can't see. So it really is tremendous, and schools use them a lot to teach the kids about astronomy and the universe. And lots of people use them to make discoveries as well. It's great stuff.
I guess the difference between top-line amateur astronomy and basic professional astronomy is getting more and more blurry these days too, isn't it?
Well, it is. The sort of things you can do these days with digital cameras, just even digital cameras that are designed to be used for day-to-day purposes, which you can use for astronomy, or you can get specialised astronomy digital cameras. You can take exposures of, tens of seconds and do the equivalent of what it would have taken exposures of hours to do in the old days using film, which you then have to develop and so on. And the beauty of it, of course, is you can take a picture with a digital camera, say of 10 seconds duration, and then you can see the results straight away and see whether you've messed it up or not. But in the old days with the film, you'd have to do the best you can to get it set up right, take your shots, and then you wouldn't find out till the next day when you started to develop your film whether anything had gone wrong. So it really is incredible. And the other thing too is that professional telescopes, the really ginormous professional observatories, they don't really typically all the time take data that is turned into pretty pictures. They're looking for data. They're measuring things. They're doing spectra. They're measuring all sorts of stuff, right? So the pretty pictures that you see around these days most often come from amateur astronomers who are producing pretty pictures that are better than the professionals could have done 20 years ago.
Wow. We've previously discussed layering when it comes to taking images of deep sky objects. This is a way of improving the quality of the resolution of the work that you're doing. Is using a video camera a good way to do that?
Yes, you can do that. In fact, someone sent me a picture the other day of the moon, the most amazing, sharp, crystal clear image of the moon. And this fellow had taken a whole series of images with the video camera, thousands and thousands and thousands of them, in fact, 56 gigabytes worth of data. And then you can use automated system software to go through all those individual images to find the best ones. And then you can sort of combine or stack all those best ones together inside the computer. And it produces a much better, clearer, sharper picture. And then you can use some other software to tidy it up or straighten it up if there are any imperfections in it. So, yeah, that is exactly what they do. You can go through and you throw out all the ones where you've got a momentarily blurry frame out of the image, and there are thousands of those. Get rid of all the bad ones and just keep the good ones and stack them or combine them all together, and you end up with a really good result.
Is it a growing hobby?
This particular one, or astronomy itself?
Astronomy itself.
Oh, yeah, look, absolutely. It's probably never been more popular, and I think a lot of that is to do with the affordability of the gear and the ease of doing astronomy now. So go back 30 years. 30, 40 years, right? There were no computer-controlled telescopes. You were using film with film cameras, and if you wanted to do long exposures in order to pick up faint objects, you would have to get your film and cool it down. So people were designing camera systems that used to have dry ice in them to keep the film cold during the exposure, or you would have to buy special film that had been soaked in hydrogen gas for ages and ages at a high temperature in order to drive out any moisture that was in the film, because moisture in film makes the film fog over long exposures. So it wasn't easy to do this sort of stuff. And you'd have to sit there at the telescope without a computer-controlled telescope. You'd have to sit there and look through this eyepiece and find a star and just using your controls in the telescope, just guide on that star for sometimes 2 hours, while the camera is doing its exposure. Because if you didn't guide the telescope, you might end up getting a blurred picture because of movement, because telescopes, don't have perfect tracking, or at least they didn't back then. So these days, you've got computer-controlled telescopes. You just switch it on. It knows where it is straight away. It aligns itself straight away. You've got your computer-controlled handset. You type in what you want to see, and it turns, and there it is, right there. Stick your camera on, take a 10-second exposure, and there you've got your picture. It really has opened it up to far more people, I think, who wouldn't have necessarily gone to all that trouble decades ago of doing it the hard way.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. And subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. This is SpaceTime. A Northrop Grumman Minotaur 4 rocket has successfully launched a classified spy satellite into orbit for America's highly secretive National Reconnaissance Office. The NROL-129 mission is the first launch of the Minotaur 4, a converted Peacekeeper intercontinental ballistic missile, from NASA's Wallops Island Flight Facility on the Virginian mid-Atlantic coast.
This is the NASA Wallops Flight Facility coverage of the launch of Northrop Grumman's Minotaur 4 rocket. The rocket is carrying a classified payload for the National Reconnaissance Office, NRO. 78-foot-tall Minotaur 4 rocket is a 4-stage vehicle, consists of 3 solid-fueled motors from decommissioned Peacekeeper ICBMs and a commercial solid rocket upper stage.
T-minus 5, 4, 3, 2, 1, ignition. Liftoff of the Northrop Grumman Minotaur rocket carrying 4 L-129 spacecraft to orbit for the National Reconnaissance Office, marking 20 years of Minotaur launches and 14 years of partnership with NASA Wallops Flight Facility and the Mid-Atlantic Regional Spaceport.
Vehicle attitude and flight path are nominal. Pitch over complete.
Check step 92, 93, 94,
Vehicle
95.
avionics power is nominal. Passing Mach 2, motor pressure nominal. T plus 36 seconds. Entering max Q. Attitude nominal.
Passing Mach 3 at maximum stage 1 thrust of over 5,000 pounds. Passing Mach 4, vehicle is half original mass.
Cooling off.
Stage 2 ignition. Stage 2 motor pressure is nominal.
Vehicle attitude and flight path are nominal.
Vehicle avionics and power systems are performing as expected.
T plus 85 seconds at maximum stage 2 thrust of over 300,000 pounds.
Attitude and flight path are nominal. Vehicle is now 1/4 of its original mass.
Approaching stage 2 burnout, followed by a 10-second coast.
Stage 2 burnout.
The mission marked the 27th consecutive successful launch of a Minotaur rocket and the 7th launch of the 4-stage Minotaur 4 variant. The 24-metre tall Minotaur uses 3 solid rocket stages from decommissioned US Space Force Peacekeeper and Minuteman ICBMs fitted with new avionics and either an Orion 38 or Star 48V commercial solid rocket upper stage. The Minotaur 4 used for this mission started its life as an LGM-118 Peacekeeper, originally known as the MX missile. These were designed to carry 12 independently targetable W-87 300-kiloton thermonuclear warheads. The Minotaur 4 is capable of launching payloads of up to 1,800 kilograms into low Earth orbit. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Early results from Phase 1 human trials of Moderna's COVID-19 coronavirus vaccine, mRNA-1273, has shown that it's able to boost immune response in all volunteers given the drug. The gold standard of protection against viral infection are neutralizing antibodies, and a report in the New England Journal of Medicine claims this vaccine is capable of inducing quite good levels of neutralizing antibodies. mRNA-1273 works by activating immune pathways by training the body to recognize proteins produced by the virus using messenger RNA. That makes it an entirely new type of vaccine, working quite differently to conventional vaccines, which usually use weakened live versions of the virus. The Phase 1 trial, which is designed to gauge if the vaccine is safe for people and how it affected their immune systems, involved 45 healthy adult participants aged 18 to 55 who were given the vaccine twice over 28 days at varying dose levels. However, there were side effects. The trials found that at 100 microgram dose levels, 80% of participants experienced chills and headaches, and just over half experienced muscle pains that were described as transient and mild or moderate in severity. The drugs yet to be tested on participants who are not in perfect health, are already suffering from COVID-19, or those who are aged over 55. A randomized placebo-controlled Phase 3 trial, including more than 30,000 participants, will begin by the end of the month. A new study has found that malware hidden in China-mandated software is far more extensive than experts had previously thought. Beijing requires all companies doing business with China, both foreign and domestic, to install what it calls tax software. And security analysts have uncovered a range of sinister Chinese Communist Party spyware lurking deep inside these so-called tax software programs. This high-stealth spyware is now infecting computers globally. It includes an app with a covert backdoor, allowing the Chinese government and its People's Liberation Army unrestricted access to computer networks. Beijing's decision to spread the new spyware globally follows the introduction of a separate piece of malware that employed equally sophisticated means to infect taxpayers' computers inside China. Security firm Trustwave has named the malware Golden Helper, after finding it hidden inside Chinese banking golden tax invoicing software, which all companies registered in China are mandated to use to pay value-added taxes. Golden Helper has been active since at least January 2018. The malware bypasses Windows' normal user account controls, thereby allowing other malicious Chinese spyware and malware programs to be installed and make hidden changes to your computer systems. The Golden Helper conceals its behavior, evading detection from antivirus software through randomly generated file names, randomly produced creation and last write timestamps, downloading executable files using fake file names with extensions such as GIF, JPEG and ZIP, hard-coded logic that uses domain lookup data to control download locations, the content downloaded, and where the content's placed, and the use of IP-based domain-generated algorithms to randomly change command server locations. The problem's so insidious, some companies have even reported the Golden Tax software, and consequently the hidden Golden Helper malware, pre-installed on their computers new, even on home editions of Windows. These latest revelations follow last month's discovery of advanced spyware dubbed Golden Spy, which was found installed on the network of a large multinational technology company which had just opened offices in China. Golden Spy infected computers using the same Golden Tax project as Golden Helper. Golden Helper was produced by a firm known as Baiwang. It was digitally signed using a Windows Trusted Certificate issued by Now Technologies, a subsidiary of Asino Corporation, the same company responsible for the tax software embedded with Golden Spy malware. Paleontologists have discovered a new species of dinosaur in Brazil. The small, lightly built theropod, named Eratosaurus musaeacionale, roamed the Earth during the Cretaceous period 104 million years ago. The findings, published in the journal Scientific Reports, indicate the fossils belong to a juvenile with an estimated body length of around 3.12 metres, that's just over 10 feet, and a body mass of around 34.25 kilograms. The new dinosaur belongs to a group known as Coelurosaurs, a large group of dinosaurs which are more closely related to birds than to carnosaurs. A new study has found a link between erectile dysfunction and watching porn. The findings, presented to the European Association of Urology Congress, showed that the more porn people watched, the greater their level of erectile dysfunction. The authors found that watching porn was associated with a greater level of dissatisfaction with so-called normal sex, with only 65% of respondents rating sex with their partner as being more stimulating than porn. The study is based on the survey of 3,267 males, focusing on their sexual activity and health over the previous 4 weeks. Researchers found respondents on average watched about 70 minutes of pornography a week, usually in sessions lasting between 5 and 15 minutes at a time. They also found that around 23% of men under 35 who responded to the survey had some level of erectile dysfunction when having sex with a partner. And those who watched more porn also scored higher on porn addiction scales. They also found that 90% of men surveyed would fast-forward the video to watch the most arousing pornographic scenes, and 20% felt that they needed to watch more extreme porn to get the same level of arousal as previously. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, CastBox, from SpaceTimeWithStuartGary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through SpaceTimeWithStuartGary.com for all the details. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.